When we introduced the idea of confidence intervals back in Chapter 8, we only dealt with confidence intervals involving one sample. Today, we'll talk about confidence intervals involving two samples. But before we get into it, let's talk about the formulas that we'll need. This is the same formula sheet that we used in the last lecture. The front page we talked about in the last lecture, these are the formulas for hypothesis tests. Today, I want to talk about the second page, which are the formulas for confidence intervals. Back in Chapter 8, when we talked about confidence intervals, the end product was something that looked like either p hat plus or minus the margin of error or x bar plus or minus the margin of error. The first one was for the one proportion situation. The second one was for the one mean situation. Today we'll talk about the two proportions and the two means situation. For the two proportion situation, the end product is going to look like P1 hat minus P2 hat plus or minus the margin of error. That's for the two proportions. The two means is going to be x1 bar minus x2 bar plus or minus the margin of error. That's for two means. And the question is, how do you find the margin of error? So it's different in each one of these situations. And that's these formulas. In general, Z stars are for proportions and T stars are for means. The first one with the Z star, that's for the one proportion situation. The second one with the T star, that's for one mean. The third one with the Z star and also P1 hat, P2 hat, that's for two proportions. The fourth one, T star, with the S1, S2, N1, N2, is for two means. The last two formulas we've seen before, these are for finding the sample size. This is in the beginning stages of your study. You're planning your study. You haven't actually done your study. This tells you how many people you should include in your sample. The first one is for proportion. The second one, even though it has a Z star, is for mean. And we talked about back in Chapter 8 why, even though this is mean, why we have to use a Z star. All of these formulas involve either a Z star or a T star. How do you find the Z star and T star? They all involve this picture, which is the same picture we've been drawing for like the last 4 or 5 chapters. For hypothesis tests, the picture could be left-tailed, right-tailed, or two tails. For confidence intervals, it's always going to be shaded in the middle. And the shaded area in the middle is the confidence level. And depending on whether you're talking about proportions or means, you're either finding the Z star or the T star. All right, so let's try some examples. Example 1. A study was done to compare the effectiveness of distance learning with traditional classroom instruction. 12 students took a business administration course online, while 14 students took it in the classroom. The final exam scores were as follows. Part A, construct a 95% confidence interval for the difference between the mean scores for the two types of instruction. The first question we need to ask ourselves is, are we talking about proportion or are we talking about mean here? It says construct a 95% confidence interval for the difference between the mean. So definitely mean. Second thing we need to ask ourselves is this a one mean or is this a two mean situation? Now here we're given the data. So anytime you're given the data, just like in the previous lecture, we have to ask ourselves, is this independent or is this a matched situation? And the way you tell is think about the two main examples of matched. The two main examples of matched are the first one, if the data represents two measurements on the same person or thing. Okay, that's the first one. The second main example of matched is if the people in the first group are related in some way to the people in the second group. Okay, so do we have those situations here? It says 12 students took it online and 14 students took it in the classroom. So this isn't a situation where one student is taking it online and then taking it again in a classroom. So these aren't scores for the same student. So definitely not that first example. Are the students in the first group related in any way to the students in the second group? All we're told in the problem is that 12 students took it online and 14 students took it in the classroom. Nothing else. So we're not told that the online group are related in any way to the classroom group. So that's not the second main example of matched. This would have to be independent then. And for independent, we run it as two means. And then just to remind myself, for means, I should be using t's throughout the problem. So this is independent. And actually, for this one, it's actually more obvious that it's independent. There's 12 students in the online and 14 students in the classroom. So it's a different sample size for the two groups. Because it's a different sample size, there's no way for you to match them anyway. So this one is more obvious that it's independent. All right, so now I'm gonna have to go to Google Sheets, enter the data, and then find the mean, find the standard deviation, and find the sample sizes. Here we are in Google Sheets. Let me enter my data. So I have online and I have classroom. So I'll enter the data as a column. I'm gonna have an online column, and then I'll have a classroom column. For online, it's 66, 75, 8. Okay, so I have the data entered. This is independent. So for independent, we run this as two means. Two means meaning we're going to treat each column separately and find the mean and standard deviation for each column separately. To find the mean, the command is going to be equals. So anytime you want Google Sheets to do any calculations, you always have to start with equals. So equals average, A-V-E-R-A-G-E, parentheses, and then highlight the online numbers. Hit enter. For the classroom, same thing, equals A-V-E-R-A-G-E, average, parentheses, highlight the classroom numbers. Those are the means. To find a standard deviation, equals STDEV, parentheses, highlight the online numbers. And then for the classroom numbers, equals STDEV, parentheses, highlight the classroom numbers. Those are my means and standard deviations. Let me go back and copy these down. All right, let me let my ones represent online, and then my twos represent classroom. So I need to write down the two means that I found and then the two standard deviations that I found. The first mean, x1 bar, is the mean for online, which was 76.75. S1 is the standard deviation for online, rounded to 3 decimal places is 8.572. And then I also need a sample size. Sample size for online, if you count these, I think there's 12. And then for my x2 bar, that's the mean for classroom, it was 80. S2 is the standard deviation for classroom, rounded to 3 decimal places is 9.348. And then N2, how many classroom students did I have? I think it's 14. And now we're ready to construct our confidence interval. This is a two means situation, so our final product should look something like x1 bar minus x2 bar plus or minus the margin of error. So the first thing I need to compute is x1 bar minus x2 bar. X1 bar is the 76.75. X2 bar is 80. And then 76.75 minus 80 is negative 3.25. Okay. Step 2 in any confidence interval question is to find the critical value Z star or T star. The critical value has to do with this picture. And for confidence intervals, it's always shaded in the middle. And the shaded area is the confidence level. For this question, we're looking for a 95% confidence level. So the shaded area is 0.95. And then we're either looking for Z stars or T stars. Here we're talking about means, so we're looking for T stars. And then this is really a area to T question. For area to T questions from the front page of our formula sheet, area to T, in the T situation is going to be QT, left area, DF. All right, so we'll do QT. Left area, so the left area of this picture, which is this left unshaded area. 0.95 is the area, the shaded area. I need to first do 1 minus 0.95. Okay, 1 minus 0.95 is 0.05. Anytime you do 1 minus on a shaded area, you get the unshaded one. So that's the left and right together. I just want the left. To get just the left, divide that by 2. So 0.05 divided by 2 is 0.025. That's the left unshaded area that I'm going to feed into R. QT has a DF. So DF generally is 1 less than the sample size. When we have 2 sample sizes, you don't combine them. You take the smaller sample size, which is the 12. 1 less than 12 is 11. All right, so we'll do QT, 0.025, comma 11, and we get negative 2.201. Okay, that refers to the one on the left. I expect 2 T stars, so our T stars are negative 2.201, and the one on the right is going to be positive, so positive 2.201. Step 3 is to find our margin of error. If we go back to our formulas, we're talking about the 2 mean situation. So the formula for margin of error for 2 means is this one. T star, big square root, S1 squared over N1, S2 squared over N2. Okay, so let me copy that down. T star, big square root, S1 squared over N1 plus S2 squared over N2. And I'm going to enter this directly into Desmos. T star. So we have 2 T stars. I always use the positive one, so I'm going to use positive 2.201. Square root. Fraction. First fraction is S1 squared over N1. S1 squared, 8.572 squared. Over N1. N1 is 12. And then move your cursor just to the right of the fraction and hit plus. Right? So you want everything inside the square root. If you go too far and you hit plus, you'll see that the plus is outside of the square root. If that happens, just move your cursor just to the right of that fraction without any spaces, hit plus, and make sure that that plus sign is inside the square root. And then I'll hit fraction again for the second fraction. S2 squared, S2 is 9.348 squared. And then over N2, N2 is 14. Okay, make sure what you see on Desmos looks exactly like this formula. In other words, everything should be inside of that square root. And then we'll hit enter. Our margin of error is 7.740. And then finally, step 4, construct your interval. So start with the x1 minus x2, which is negative 3.25, plus or minus the margin of error, 7.740. And then I want the low number and also the high number. So the low number, we negative 3.25 subtract. Minus 7.740. Our low number is negative 10.99. Our high number, negative 3.25 plus 7.740. Our high number is 4.49. And that's our confidence interval. Part B, state your result in part A in a complete sentence. So the sentence we want to write for all confidence intervals is state your confidence level. So we are 95% confident that, what are we talking about here? That the difference between the mean scores for the two types of instruction is between negative 10.99 and 4.49. So this is not proportion, so you don't convert this to percents. So it's negative 10.99 and 4.49 points. Part C. Based on the confidence interval, can you conclude that there is a difference in the effectiveness of the two methods of instruction? Okay, can you conclude that there is a difference? What does this mean? So let me talk about some English here. What does it mean to be the same? So being the same So another way to say being the same is that there's no difference, right? Being the same is the same thing as saying there's no difference, which is the same thing as saying that the difference is zero. Okay? Now, what does being different mean? So different, if being the same means that the difference is zero, then being different means that the difference is not zero. Now, basically what this question is asking is, can you conclude that there is a difference? Can you conclude that the difference is not zero? So can we conclude that the difference is not zero? And all you know is that the difference is somewhere between negative 10.99 and 4.49. So can you say for sure that the difference is not zero? No, you cannot, right? Because you know that the difference is somewhere between negative 10.99 and 4.49, which means the difference could be zero, right? Zero is between negative 10.99 and 4.49, right? Zero is between those two numbers, which means it could be zero. So you can't say for sure that it's not zero. This is a no. Example 2. In order to judge the effectiveness of an advertising campaign for a certain brand of pretzel, a company obtained a simple random sample of 90 convenience store receipts the week before the ad campaign began and found that 21 of them showed a purchase of the pretzels. Another simple random sample of 70 receipts were taken the week after the ad campaign, and 39 of them showed a pretzel purchase. Construct a 98% confidence interval for the difference between the proportions of customers purchasing pretzels before and after the ad campaign. First thing we need to decide is, are we talking about proportions or are we talking about means? Construct a 98% confidence interval for the difference between the proportions. This is for sure proportions. And then we have to decide whether we're talking about one proportion or two proportions. difference between proportions of customers purchasing pretzels before and after, right? So we have a sample before, right? We took a sample of 90 receipts before, and then we also took a sample of 70 receipts after. This is definitely going to be two proportions. And then just to remind myself, for proportions, I should be using z's throughout this problem. All right, so two proportions. If I look at my formula sheet, two proportions, the end result should be P1 hat minus P2 hat plus or minus the margin of error, which means the first thing I need to do is find this part, P1 hat minus P2 hat. And I need to label what I mean by ones and what I mean by twos. So we have a sample before and a sample after. So let's call the ones before and the twos after. And I need to find P1 hat and I need to find P2 hat before I subtract them. So P1 hat should be the proportion before. So we're talking about pretzels here, well, receipts, and then how many of those receipts bought a pretzel. So proportion of receipts that have pretzels before. For the before, 90 receipts before, and then 21 of them had pretzels. So our proportion before is 21 out of 90. And then we'll calculate that later. P2 hat is the proportion after. So for after, we had 70 receipts total, and 39 of them had a pretzel. So this is 39 out of 70. All right, so P1 hat is 21 over 90. Round this to 3 decimal places is 0.233. P2 hat, 39 over 70. 0.557, which means now I can do the subtraction. P1 hat minus P2 hat is going to be 0.557 minus 0.233. Actually, let me do that down here. (0.557) minus 0.233. 0.324. Okay, that's my part one. P1 hat minus P2 hat. Now, step 2 is to find a critical value Z star or T star. Critical value always has to do with this picture. And for confidence intervals, it's always shaded in the middle. And the area in the middle is the confidence level. Our confidence level here is going to be 98% confidence. That's the area in the middle, 0.98. And then we're talking about Z's here. We're looking for Z stars. And then if I go back to the front page of my formula sheet, this is really an area to Z question. So area to Z for the Z situation is a Q norm. So we're going to Q norm left area. Left area of this picture, 0.98 is the area in the middle. To get the unshaded part, I'm going to first do 1 minus 0.98. That should give me the unshaded part, 0.02. The unshaded part is the left and right together. If I just want the left side, what do? Divided by 2. 0.02 divided by 2. 0.01. That's the left unshaded part that I'm going to plug into R. So 0.01. Q norm doesn't have a DF, so that's all I need. Q norm 0.01. Negative 2.326. Okay, I expect two z stars. So one of them is negative 2.326, and the other one on the right side is going to be positive 2.326. All right, step 3 is to actually calculate your margin of error E. Let's look for the correct formula for margin of error here. This is a two proportion situation. For two proportions, we're using this one. Z star and then big square root with a whole bunch of stuff inside. So let me copy that down. This is going to be Z star, big square root. Inside it's going to be P1 hat, 1 minus P1 hat over N1 plus P2 hat, 1 minus P2 hat over N2. And make sure both of those fractions are inside that square root. All right, so let's try to enter this into decimals. So we're going to first start with Z star. I have two Z stars, but I'm always going to use the positive one. So 2.326 square root fraction. Okay, first fraction is going to be P1 hat, 1 minus P1 hat over N1. P1 hat is 0.233. Parentheses 1 minus 0.233 over N1. Sample size for my ones. So sample size for before should be the bottom of that first fraction. So 90. Okay. Plus. So here's where you want to move your cursor just to the right of the fraction and hit plus. Make sure that plus is inside the square root. And then hit another fraction. Make sure that fraction is also inside that square root. Second fraction, P2 hat. P2 hat is 0.557. Parentheses 1 minus 0.557 over N2, sample size for my 2's. So sample size after was 70. Okay. Hit enter, 0.173. And then finally, step 4, to construct your actual confidence interval. Start with your step 1, which was the 0.324. Okay, that was actually P1 hat minus P2 hat. Plus or minus the margin of error, 0.173. And then I want my low number and high number. To get my low number, subtract 0.324 minus 0.173. 0.151 is my low number. My high number, plus 0.324 plus 0.173, 0.497. And that's my confidence interval. Part B, state your result in part A in a complete sentence. So same sentence as we always write. We are, state your confidence level. We are 98% confident. That, what are we talking about here? Difference between the proportions of customers purchasing pretzels before and after the ad campaign. That, the difference between the proportions purchasing pretzels before and after the ad campaign is between. Now, this is proportions, so we should convert these to percents. So between 15.1% and 49.7%. Okay, so you're only converting to percentage on the proportions. Now, part C. Based on the confidence interval, can you conclude that the proportion of customers who purchase pretzels changed? Change is the same thing as asking, is it different or differs? After the ad campaign. So this is really the same question that we asked on the first example. And different means that can you conclude that the difference is not zero? So this is the same thing as asking, can you conclude that the difference is not zero? So based on our confidence interval, can we say that the difference for sure is not zero? We know the difference is somewhere between 15.1% and 49.7%. Can you say for sure that the difference is not zero? Yes, right? We know it's somewhere between 15.1 and 49.7. None of those numbers in between are zero, so we know for sure it has to be not zero. So this is a yes. Because none of the numbers between 15.1% and 49.7% are zero. There's one last thing I want to mention here. This last question, part C, where it's asking, can you conclude that the proportion of customers before differs from the proportion of customers after? That type of question should sound familiar, right? We asked and answered those types of questions already when we talked about hypothesis test. And differs would have been a two-tailed hypothesis test. In a hypothesis test, though, the end result is always just a yes or no, right? Either yes, there is enough evidence to conclude that the proportions differ, or no, there is not enough evidence to conclude that the proportions differ. Yes or no answer. If there's a difference, sometimes we would like to know how big the difference is, right? The size. And that's not something a hypothesis test is going to tell you, but a confidence interval will. Right here, we're able to say that yes, there is a difference, and also that the size of the difference is somewhere between 15.1% and 49.7%. So hypothesis tests and confidence intervals are really two sides of the same coin. So when you encounter situations like this, you actually run both of them. You run hypothesis tests together with confidence intervals. The hypothesis test will answer your yes-no questions, and the confidence interval will give you an estimate of the size of things. Example 3. A group of 8 individuals with high cholesterol levels were given a new drug that was designed to lower cholesterol levels. Cholesterol levels in milligrams per deciliter were measured before and after treatment for each individual with the following results. Construct a 90% confidence interval for the mean reduction in cholesterol level. Okay, first thing we need to decide is, are we talking about proportions or are we talking about mean? Construct a 90% confidence interval for the mean. So definitely a mean. And the question is, are we talking about one mean or are we talking about two means? Anytime you're given data, right, you have to ask yourself, is this independent or is this matched? So the two main match situations, the first one is two measurements on the same person or thing, or if the people in the first group are related in some way to the people in the second group. Here, right, we're told that the cholesterol levels were measured before and after treatment for each individual. So before and after for each individual. So these measurements represent before and after measurements on the same person, right? Before and after on the first person, before and after on the second person. So this is before and after on the same person, which is the first example of matched. So this is a matched situation. And for matched situations, we do this as a one mean. And then to remind myself, means, I should be using t's. And the reason why it's one mean is because if it's matched, what you're actually going to do is you're going to find the differences. And then work with the differences. So that's your one sample that you're going to work with. So let me switch over to Google Sheets and enter this data. All right, we're back in Google Sheets. Let me enter my before and after data as columns. So let me just enter it over here. Before, after, before, 283, 299. All right, I have my data entered. Now, this is a match situation. So for a match situation, you're going to create a third column called differences, where you're going to subtract. Okay, So I want to set up this first box so that it subtracts. So to get Google Sheets to do anything, to calculate anything for you, you always have to start off with equals. So equals. And then I want to do before minus after. So I'm not going to type anything in. I'm going to click. So click on the 283, the before, minus, click on the 215, the after, and then hit enter. Okay, it's going to have an autofill. You can use the autofill. It's usually correct. Or you can also click on that first box, move your cursor to the bottom right, that square until you see a plus sign, and then click and drag. So it does the same thing. It's basically just copying that first box and then pasting it for the rest of the column. All right, so because it's matched, we're just going to work with the one differences column. So that's why it's one mean. And we're going to find the mean and standard deviation for just the differences. So to find the mean, equals average, A-V-E-R-A-G-E, parentheses, and then highlight the differences. And to find the standard deviation, equals STDEV, parentheses, and then highlight the differences. And that's the mean and standard deviation that we'll use. All right, the mean we found was 79.375. The standard deviation we found, S, was 13. Round to 3 decimal places is 13.384, and then the sample size. Sample size of just the differences, so there would have been 1, 2, 3, 4, 5, 6, 7, 8 differences. Or go to your Google Sheets and count how many differences there are. There's 8. All right, so part A, construct the confidence interval. So this is a one mean. One mean, our end result should be X bar plus or minus the margin of error. So for my first step, I should just have the X bar, which is just this, 79.375. Step 2, find your Z star or T star critical value. So critical values have to do with this picture. And it's always shaded in the middle. And the shaded area is the confidence level. Confidence level here is 90% confidence. That's the shaded area in the middle. Then we're either finding Z star or T stars. We're talking about means here, so it should be a T star. And then this is a area to T problem. Area to T. Area to T for the T situation is QT, left area DF. And so we do QT, left area DF. Left area of this picture is this left unshaded part. Shaded part is 0.90. I'm going to first do 1 minus 0.90. That should give me the unshaded part. 1 minus 0.90 is 0.1. That's the unshaded part, which is the left and right together. If I just want the left, we'll divide that by 2. 0.1 divided by 2. 0.05. Okay, that's the left unshaded area that will plug into R. QT has a DF, so degrees of freedom. We just have one sample, so our sample size is 8. One less than that is our degrees of freedom, so that's 7. So we'll do QT 0.05, comma 7. And it's a negative 1.895. I should have 2 T stars. The first one is, the left one is negative 1.895. The one on the right should be positive 1.895. Step 3 is to find our margin of error using the correct formula. We're doing one mean. One mean margin of error would be this one. Let me copy that down. T star S over square root n. And then let me type this into Desmos. T star, I have a negative and a positive. I always use the positive one. So positive 1.895. and then times fraction. S is this 13.384, a standard deviation, so 13.384 over square root n, or n is 8, square root of 8, and then hit enter. So our margin of error is 8.967. And then finally, step 4, construct your confidence interval. So take your answer from step 1, 79.375, plus or minus the margin of error, plus or minus 8.967. And then to get my low number, subtract 79.375 minus 8.967, 70.408. And then my upper number, add 79.375 plus 8.967, 88.342. And that is your confidence interval. Part B, writing the sentence. We are, state your confidence level. So we are 90% confident. That, what are we talking about here? The mean reduction in cholesterol level, that the mean reduction in cholesterol level is between 70.408. This is we're talking about means here, so you don't convert this to percents. 70.408 and 88.342. So these are cholesterol levels. These should be what? Milligrams per deciliter. Those are the units for cholesterol level. Part C. Based on the confidence interval, can you conclude that the mean reduction in cholesterol level is more than 70? This one isn't asking about differs, right? So we're just asking, can you say for sure that the difference is more than 70? And all you know is that the difference is somewhere between 70.408 and 88.342. So can you say that for sure it's more than 70? Yes, right? 70.408 is more than 70. 88.342 is more than 70, which means all the numbers in between are going to be more than 70 for sure. So this is a yes. Example 4. A survey of college students reported that in a sample of 413 male college students, the average number of energy drinks consumed per month was 2.49 with a standard deviation of 4.87. And in a sample of 382 female college students, the average was 1.22 with a standard deviation of 3.24. Construct a 99% confidence interval for a difference between men and women in the mean number of energy drinks consumed. Question is, are we talking about proportions or means here? Construct a 99% confidence interval for a difference between men and women in the mean. So definitely mean. And the question now is it one mean or is it two means? Now, we talked about a couple mean examples already. We talked about means in example 1, and we talked about means in example 3. Now, in both of those examples, I gave you data. And when I give you data, the next question you have to ask yourself is it independent or is it matched? Because if it's independent, you run it as two means. If it's matched, you run it as one mean. Now here, I'm not giving you data. So if I don't give you data, it has to be independent. Which means you're going to run it as two means. And then to remind myself, I should be using t's. And the reason why it's independent is because it can't be matched. For match, remember, we have to find the differences. And if you don't have the data, you can't find the differences. So you can't do it as a matched anyway. This is independent. The difference between this independent and example 1, in example 1, I gave you the data, so our next step would have been to enter the data into Google Sheets in order to find the mean and standard deviations of those two samples. Here, the mean and standard deviations are given to you in a problem, right? And you just have to write it down. So here we have, I need x1 bar, standard deviation 1, and sample size 1. Then I need mean 2, standard deviation 2, sample size 2. Let's let my 1s be the men, and then my 2s be the women. X1 bar, that's the mean for the men. The mean for the men was 2.49 with a standard deviation of 4.87. So 2.49 for the mean, 4.87 for the standard deviation. N1, sample size for the men, 413 male college students, 413. Women, the mean for the women was, the average was 1.22 with a standard deviation of 3.24. So S2, standard deviation for the women, 3.24. N2, sample size for the women, 382 female college students, 382. Then from here, you do exactly what we did in example 1. So from here, I'm going to say same as example 1. And I won't finish this off. All right, that's it for today. Have a good day. I will see you in the next one.